All right, so get this. What if AI could learn like it's cramming for an exam?
Mm.
We're diving into some seriously cool research that explores just that. I was checking out this paper you sent over about something called test time training for AI,
hmm
and it seems like it can unlock some pretty surprising problem-solving skills.
Yeah, it's a fascinating concept. This research uses visual puzzles,
Okay.
the kind that really test your ability to think abstractly.
Right.
And it shows how AI can actually get better at solving them during the test itself.
I'm already hooked. Okay, so
Yeah.
these visual puzzles, they're not your average Sudoku, right?
Right.
What makes them so special that they can actually tell us something about AI's reasoning abilities?
Well, they're part of something called the Abstraction and Reasoning Corpus, or ARC for short. Imagine like a grid with shapes on it.
Okay.
The puzzle might involve like mirroring those shapes,
Uh-huh.
but ARC goes way beyond that. We're talking multi-step transformations, hidden rules,
Wow.
the kind of stuff that makes even us humans scratch our heads.
Okay, so these puzzles are designed to be tough nuts to crack. But how does this test time training actually work?
Hmm.
Is it like giving the AI a cheat sheet right before the exam?
Not exactly. It's more like giving the AI a targeted study session. The idea is to take the puzzle that the AI is trying to solve, right, and generate a bunch of similar mini puzzles from it.
Okay.
Then, right before the AI tackles the main puzzle, we quickly train it on these mini puzzles.
So it's like a last-minute cram session, but for AI. But does it
Yeah.
actually work? Can AI really learn that quickly
Yeah.
and apply it to a brand new problem?
The results are surprisingly effective.
Really?
Researchers found that using test time training, or TTT, could increase the accuracy of an AI model by a factor of 6.
Hold on, 6 times? That's a massive jump.
It is.
I'm starting to see why you're so excited about this.
Yeah.
This really seems like TTT could be a game changer for AI.
Yeah.
But like any good training program, there must be some key ingredients to make it work.
Right. That's right. The researchers found that TTT isn't just about, randomly throwing mini puzzles at the AI.
Right.
The way those mini puzzles are crafted,
Yeah.
the type of pre-training the AI has undergone.
Yeah.
These factors all play a crucial role in its success.
Okay, let's break down this recipe for TTT success. What are some of the essential elements?
So one key ingredient is something called the leave one out method.
Okay.
Imagine you're trying to understand a pattern by covering up one part at a time.
Okay.
That's essentially what the AI does during this process. It helps the AI identify and learn the underlying rules of the puzzle.
So it's learning to fill in the blanks, literally.
Yeah.
What else makes TTT so effective?
Another important aspect is something called augmentation.
Mm.
Imagine taking the same basic puzzle and then, rotating it, flipping it, or even changing the colors of the elements.
Right.
This forces the AI to look beyond the superficial appearance and grasp the deeper concepts at play.
So it's like training for a marathon in all kinds of weather conditions.
Yes.
It makes you more resilient and adaptable, right? But isn't this a ton of work for the AI?
It is.
I mean, solving the same puzzle multiple times with all these variations.
It does require some extra effort, but that's where augmented inference comes in. This technique allows the AI to kind of double check its work.
Okay.
After solving the puzzle with different transformations applied, the AI essentially votes on the most likely correct answer. This self-consistency check helps to significantly boost accuracy.
So it's like having a built-in study buddy to compare answers with.
Yeah.
This is all incredibly fascinating. But before we go any further,
Sure.
I have to ask, what about the AI's training before all this test time magic?
Right.
Does that play a role too?
Absolutely. The initial training lays the groundwork for everything that follows.
Okay.
The researchers experimented with different approaches, including using a special language designed for describing these visual puzzles,
Wow.
and even having another AI generate new training puzzles.
Wait, AI designing homework for other AI? That's wild. Did it work?
Interestingly, training on those AI-generated puzzles wasn't as effective as using human-design ones. It seems like we humans still have a bit of an edge when it comes to crafting those brain-bending challenges.
So we've got this powerful combination of pre-training and test time training.
Yeah.
What happens when we put it all together and actually test it out?
Well, the researchers tested their method against the standard ARC benchmark.
Mm-hmm.
And get this, their TTT method, combined with another system called BRC, managed to achieve an accuracy of 61.9%.
61.9%.
Mm-hmm.
That's amazing. Wait, what's BRC and how does it fit into all of this?
BRC is another system designed to tackle ARC puzzles. It's what we call a hybrid
Hmm.
system, combining the strengths of neural networks with something called program synthesis.
Okay.
And when they combined TTT with BRC, they found that it actually matched average human performance on the benchmark.
Whoa, AI that can reason as well as the average person.
It's pretty remarkable.
This is mind-blowing. But let's back up for a second. What exactly is program synthesis, and why is it important in this context?
Imagine having an AI that can write code to solve problems.
Wow.
That's essentially what program synthesis is all about.
Yeah.
In the case of ARC, it means that BRC can generate programs that represent the steps needed to solve those visual puzzles.
It was like having an AI programmer working behind the scenes,
Yeah,
figuring out the logic of the puzzles.
exactly.
And by combining this with TTT, they were able to reach human-level performance. That's incredible.
Yeah, it's a really interesting result.
Okay, this is officially blowing my mind. So we're talking about AI that can not only learn in the moment, but can also potentially be applied to all sorts of different fields.
Right.
What does this mean for the future of AI? Could this be a step towards something like artificial general intelligence or AGI?
It's certainly a step in that direction. AGI refers to AI that can understand and reason across a wide range of tasks,
Yeah.
just like humans. TTT shows us that AI can be incredibly adaptable
Right.
and capable of rapid learning, which are essential characteristics of AGI.
This is truly groundbreaking stuff. But before we get ahead of ourselves, let's dive a little deeper into how TTT works its magic.
Okay.
What are the specific mechanisms that allow AI to learn so effectively during a test?
So one key aspect is that TTT allows the AI to fine-tune its internal parameters, which are essentially the knobs and dials that control its behavior.
Gotcha.
By adjusting these parameters in response to those mini-puzzles, the AI can adapt its problem-solving strategies to the specific challenges of the main puzzle.
So it's like giving the AI a set of specialized tools for each puzzle. But how does it know which tools to use and how to use them effectively?
That's where the pre-training comes in. The initial training exposes the AI to a wide range of concepts and problem-solving techniques, giving it a foundation to build upon.
Yeah.
During TTT, the AI draws upon this knowledge and adapts it to the specific task at hand.
So it's like having a toolbox full of different skills
Exactly.
and then learning how to combine them in creative ways to solve new problems.
Yeah, that's a great way to put it.
And this ability to combine and adapt existing knowledge is a hallmark of human intelligence.
It is.
TTT suggests that we may be able to replicate this ability in AI,
Yeah,
which is a significant step towards AGI.
it is.
This is all incredibly exciting, but I'm also curious about the limitations of TTT.
Uh-huh.
Are there any potential drawbacks or challenges that we need to be aware of?
So one challenge is the computational cost.
Okay.
TTT requires more processing power than traditional AI methods, especially when dealing with complex problems. However, as computing power continues to advance,
Right.
this limitation may become less significant over time.
So it's a matter of scaling up our technology
Right.
to keep pace with the demands of TTT.
Exactly.
What other challenges do you see?
Another potential concern is the risk of overfitting.
Okay.
If TTT is not implemented carefully, the AI could become too specialized in solving a particular type of puzzle without truly understanding the underlying principles. It's like cramming for a test and acing it,
Right.
but then forgetting everything the next day.
That makes sense. We don't want AI that's just a one-trick pony.
Exactly. The goal is to develop AI that can generalize its knowledge and apply it to a wide range of situations. Researchers are actively exploring ways to mitigate the risk of overfitting in TTT by using techniques like regularization and data augmentation.
Uh-huh.
These techniques help to ensure that the AI doesn't just memorize specific solutions, but actually learns the underlying concepts.
Okay, so it's about finding the right balance between specialization and generalization.
Precisely. And that's an ongoing challenge in AI research.
Right.
But despite these challenges, TTT holds immense promise for the future of AI.
We've covered a lot of ground here. Let's take a quick recap before we move on.
Sure. We started by discussing ARC, a set of visual puzzles designed to test abstract reasoning in AI. We then explored TTT, a technique that allows AI to learn during a test by training on similar mini-puzzles. We saw how TTT led to significant improvements in accuracy, even matching human-level performance on the ARC benchmark. We discussed the key ingredients of TTT, such as the leave one out method and data augmentation. We also talked about the role of pre-training in laying the foundation for TTT's success. And finally, we touched upon some of the challenges and limitations of TTT, such as computational cost and the risk of overfitting.
That's a great summary. But before we wrap up this part of our deep dive,
Yeah.
I want to touch upon one more point that you mentioned earlier, the possibility of TTT contributing to the development of AGI. Could you elaborate on that a bit more?
Of course. AGI, or artificial general intelligence, is a hypothetical type of AI that would possess the same cognitive abilities as humans.
Right.
It'd be able to understand, learn, and reason across a wide range of domains, just like we do. And while we're still a long way from achieving AGI, TTT offers some tantalizing clues about how we might get there.
What specifically about TTT makes you think it could be a stepping stone to AGI?
Well, one of the key characteristics of human intelligence is our ability to learn and adapt quickly to new situations. We don't need to be explicitly programmed for every possible scenario.
Right.
We can take what we already know and apply it to novel challenges. And that's precisely what TTT enables AI to do. It allows AI to learn on the fly, adapt to new information, and solve problems it's never encountered before.
So in a sense, TTT is giving AI a taste of what it's like to think more like a human.
That's a great way to put it.
Yeah.
TTT is by no means a complete solution to the AGI puzzle, but it's a promising step in the right direction. It shows us that we can create AI systems that are not just limited to narrow tasks, but can learn and adapt in ways that were previously thought to be exclusive to biological intelligence.
This is incredibly exciting. It sounds like TTT could be a key that unlocks a whole new level of AI capabilities. But as with any powerful technology, there are also potential risks and ethical implications that we need to consider carefully.
Absolutely. As we develop increasingly sophisticated AI systems, it's crucial that we do so responsibly and ethically.
Yeah.
We need to ensure that these systems are aligned with human values and are used for the benefit of humanity.
That's a conversation for another time, perhaps. But for now, I think we've given our listener plenty to chew on.
Indeed, we've covered a lot of ground in this first part of our deep dive. We've explored the intricacies of TTT, its potential applications, and its implications for the future of AI. And as we delve deeper into this research, I think you'll find that the implications are even more profound than we've hinted at so far.
All right, listener, get ready for part 2. We're going to unpack some more of the fascinating details of this research, exploring the specific ways TTT is implemented and the challenges researchers are facing. And we'll continue to ponder the bigger picture. What does this all mean for the future of AI and its role in our world?
Stay tuned. So, one thing that really struck me about this research is how it highlights the importance of diversity in AI development.
Diversity? How so?
Well, remember how we talked about the AI-generated training puzzles
Right.
not being as effective as the human-designed ones?
Right. It seemed like the AI was missing that creative spark,
Yeah,
that ability to come up with truly challenging problems.
exactly. And that got me thinking about, the broader implications for AI development.
Okay.
If we only rely on AI to generate training data,
Uh-huh.
we risk creating a kind of echo chamber,
Right.
where AI systems are only exposed to a limited range of perspectives and problem-solving approaches.
So it's like raising a child in a bubble,
Mm-hmm.
sheltered from the real world.
Yeah.
They might learn a lot,
Right.
but they'll lack the resilience and adaptability that comes from facing diverse challenges.
That's a great analogy. And it underscores the importance of human involvement in AI development.
Yeah.
We bring our own unique experiences, biases, and creative insights to the table.
Yeah.
And that diversity of thought is crucial for pushing AI systems to their limits and ensuring that they're capable of tackling the complexities of the real world.
It seems like we're talking about more than just technical diversity here. It's also about cultural diversity, different ways of thinking and approaching problems.
Absolutely. Imagine an AI system that's only trained on data from a single culture or demographic.
Yeah.
It's likely to inherit the biases and limitations of that narrow perspective. But if we train AI systems on data that reflects the full spectrum of human experience, we have a better chance of creating AI that's truly intelligent and beneficial to all of humanity.
This is a really important point. It's not just about making AI smarter. It's about making it fairer and more representative of the world we live in. And that requires a conscious effort to ensure that the data we use to train AI is diverse and inclusive.
Couldn't agree more.
Yeah.
It's a responsibility that all of us in the AI community need to take seriously.
Okay, let's shift gears a bit
Sure.
and dive into some more technical details about TTT.
Oh, okay.
We've talked about the high-level concepts, but I'm curious about the nuts and bolts of how it's actually implemented.
Sure, let's get under the hood a bit. Remember how we discussed the AI adjusting its internal parameters during PTT?
Right.
Those parameters are essentially numerical values that control how the AI processes information,
Yeah.
and they're constantly being tweaked and refined as the AI learns.
Right. It's like those dials and knobs on a sophisticated machine, each one influencing how the machine operates.
Exactly. And during TTT, the AI focuses on adjusting a specific subset of these parameters,
Okay.
those that are most relevant to the task at hand. It's like a mechanic fine-tuning an engine for optimal performance.
So instead of overhauling the entire engine,
Yeah.
they're making targeted adjustments to the parts that matter most.
Right.
Clever. But how does the AI know which parameters to adjust and how much to adjust them? It seems like a delicate process.
It is, and this is where the magic of machine learning algorithms comes in.
Okay.
These algorithms are designed to analyze the data and identify the parameters that have the biggest impact on performance.
Uh-huh.
They then make, incremental adjustments to those parameters,
Yeah.
testing and refining the AI's behavior until it reaches a desired level of accuracy.
So it's like having an AI mechanic with a super sensitive set of tools, able to make minute adjustments and instantly see the results.
Yeah.
Incredible. But doesn't this process require a lot of computational power?
It can.
I mean, constantly tweaking and testing those parameters.
You're right. TTT can be computationally intensive, especially in dealing with large and complex data sets. But remember, we're talking about training the AI on those mini puzzles, which are much smaller and simpler than the main puzzle.
Right.
This helps to reduce the computational burden
Okay.
and makes TTT more practical to implement.
So it's like doing practice drills before the big game. It allows the AI to warm up its cognitive muscles
Exactly.
without getting overwhelmed.
Yeah.
Makes sense. But even with these optimizations, it seems like TTT would still be a resource-intensive process.
It can be.
Are there any efforts to make it more efficient?
Absolutely. Researchers are constantly working on ways to optimize TTT algorithms and make them more efficient. One promising approach is to use something called meta-learning,
Okay.
which essentially involves training the AI to learn how to learn.
Hold on. AI learning how to learn. That sounds like something straight out of science fiction. How does that even work?
It's a fascinating field. In meta-learning, the AI is exposed to a variety of learning tasks, right?
Okay.
And learns how to adapt its learning strategies based on the specific characteristics of each task. This means that when it encounters a new task, like those ARC puzzles, it can quickly and efficiently identify the optimal learning approach.
So it's like having an AI student who's not just good at memorizing facts,
Right.
but also knows how to study effectively and adapt to different learning environments.
Yeah,
That's pretty amazing.
it is. And it has the potential to revolutionize the way we develop AI systems.
Yeah.
Imagine an AI that can learn new skills and solve new problems without requiring massive amounts of training data or computational resources.
That would be a game changer. It would open up a whole new world of possibilities for AI applications.
You would.
But before we get carried away with all the potential benefits, let's touch upon some of the challenges and limitations of TTT.
Okay.
We talked about computational cost, but what other hurdles are researchers facing?
So one of the biggest challenges is ensuring that TTT doesn't lead to overfitting,
Right.
as we mentioned earlier.
Right, overfitting occurs when the AI becomes too specialized in solving a particular type of problem and fails to generalize its knowledge to new situations.
Exactly.
It's like training a dog to fetch a specific ball.
Yeah.
It might be a champion at fetching that ball,
Right.
but completely clueless if you throw a different one.
Exactly. And in the context of TTT, overfitting can happen if the AI focuses too much on memorizing the solutions to those mini puzzles without truly understanding the underlying concepts.
So how do researchers address this challenge?
Right.
How do they ensure that the AI is actually learning and not just memorizing?
So there are several techniques they employ, one of which is called regularization. Regularization essentially involves adding constraints to the learning process, preventing the AI from becoming too fixated on any particular set of features or patterns in the data.
So it's like setting boundaries for the AI,
Yes.
guiding it towards a more balanced and generalized understanding of the problem.
Precisely. And another technique is data augmentation,
Right.
which we discussed earlier.
Right.
By exposing the AI to different variations of the same puzzle, such as rotations, flips, and color changes,
Yeah.
researchers can help the AI develop a more robust and flexible representation of the underlying concepts.
It's like showing the AI the problem from different angles,
Yeah.
forcing it to think critically and
Right.
avoid jumping to conclusions based on superficial similarities.
Exactly. And these techniques, along with others being developed, are crucial for ensuring that TTT leads to genuine learning and not just superficial memorization.
This is really fascinating stuff, but I'm also starting to realize that TTT is just one piece of a much larger puzzle.
Uh-huh.
We've talked about its potential to contribute to AGI,
Right.
but there's so many other factors at play. What other research areas are you excited about that you think might be important for achieving AGI?
Well, one area that's closely related to TTT is meta learning, which we touched upon earlier.
Yeah.
Meta learning is all about teaching AI to learn how to learn.
Right.
And as we discussed, this has the potential to significantly accelerate AI development.
Right.
By enabling AI systems to learn new skills and adapt to new situations much more efficiently.
It's like giving AI the ability to learn independently
Yeah,
without needing constant hand-holding from human programmers.
exactly. And that's a crucial step towards AGI. Another area I'm particularly excited about is neuro-inspired AI, which involves drawing inspiration from the structure and function of the human brain
Right.
to design new AI architectures.
So we're talking about AI that's modeled after the most complex and sophisticated learning machine we know of, our own brains.
That's right. And while we're still a long way from replicating the full complexity of the human brain,
Right.
neuro-inspired AI has already led to some impressive breakthroughs,
Yeah.
particularly in areas like computer vision and natural language processing.
It seems like there's a growing convergence between neuroscience and AI research.
That there is.
Each field is informing and inspiring the other.
Absolutely. And I think this interdisciplinary approach is essential for unlocking the secrets of intelligence and creating AI that's truly capable of understanding and reasoning about the world as we do.
This is all incredibly exciting,
It is.
but I can't help but feel a sense of awe at the sheer complexity of the challenge.
Yeah.
AGI seems like such a distant goal, almost like a moonshot.
I understand that sentiment. AGI is arguably the grandest challenge in all of science and engineering. But I'm optimistic about the future.
Okay.
The progress we've made in AI in recent decades is truly remarkable.
Yeah.
And with continued research and collaboration across disciplines,
Uh-huh.
I believe we're on the right track to achieving AGI, perhaps even sooner than we think.
It's a journey full of unknowns, but one that's filled with incredible potential. And I'm eager to see where it takes us. But for now, let's pause here and give our listeners some time to digest all this information.
Good idea.
We've covered a lot of ground in this second part of our deep dive. We've delved into the technical details of TTT, explored the challenges of overfitting, and touched upon other exciting research areas that could contribute to the development of AGI. And in the final part of our deep dive, we'll explore the broader implications of TTT and the potential impact it could have on society as a whole.
Sounds good.
So listener, buckle up for part 3. We're going to delve into the philosophical and ethical dimensions of this research, examining the questions that TTT raises about the nature of intelligence, consciousness, and the future of humanity.
Stay tuned. It's going to be a thought-provoking ride.
Okay, so we've taken this journey deep into the technical world of test-time training, seen how it pushes AI to learn on the fly, and even, touched on its implications for something as grand as artificial general intelligence.
Right. And, as we've explored these advancements, it's clear that TTT isn't just some isolated phenomenon.
Right.
It's part of a much larger trend in AI,
Okay.
a shift towards systems that are more adaptable, flexible, and perhaps even creative.
Creative AI. Now, that's a concept that sparks all sorts of questions. We talked about it earlier when we were discussing AI-generated puzzles, not quite matching the ingenuity of human-designed ones.
Right.
What is it about human creativity that still seems to elude AI, even with techniques like TTT?
Well, that's a question that philosophers and scientists have been grappling with for centuries.
Yeah.
What is creativity, really? Is it simply the ability to combine existing ideas in novel ways? Or is there something more, like a spark of intuition, a leap beyond logic that AI hasn't quite grasped yet?
I love how this deep dive is taking us beyond the code and algorithms into the realm of philosophy and what it means to be intelligent.
It is fascinating.
If AI can learn rapidly with TTT, can adapt to new information, even perform at human levels on certain tasks, is it fair to say that it's exhibiting some form of intelligence?
Well, that depends on how you define intelligence.
Okay.
We focus purely on problem-solving abilities. Then AI is undoubtedly showcasing, impressive intelligence. But if we expand the definition to include things like consciousness, self-awareness, or even emotions,
Right.
then the answer becomes much more complex.
It's like we're hitting the boundaries of what we currently understand
Yeah,
about both AI and our own minds.
it's true.
Is it possible that AI could someday achieve consciousness? Or is that a line we believe it will never cross?
Well, that's a question that fuels countless debates in science fiction stories. Currently, there's no scientific consensus on whether consciousness is an emergent property of complex systems or something fundamentally unique to biological beings.
Right.
And until we have a clearer understanding of consciousness itself,
Yeah.
it's difficult to say whether AI could ever possess it.
It's a mystery that might take generations to unravel.
It might.
But in the meantime, we have AI systems that are rapidly becoming more capable, more adaptable, and more integrated into our lives. What are your thoughts on the potential impact of TTT and similar techniques on society?
The potential is vast and honestly, a bit daunting to consider.
Yeah.
Imagine AI assistants that can truly understand your needs and preferences,
Right.
learning and adapting to your individual quirks in real time. Picture medical diagnoses that are personalized to your unique genetic makeup and lifestyle. Envision scientific discoveries being made at an unprecedented pace as AI collaborates with human researchers, pushing the boundaries of knowledge.
Those are some incredibly exciting possibilities.
They are.
But I can also see the flip side, job displacement,
Right?
ethical dilemmas around AI decision-making, perhaps even the fear of AI surpassing human control.
Sure.
It's a lot to wrap our heads around.
It absolutely is. And it highlights the critical importance of having thoughtful discussions about AI ethics, governance, and the potential societal impacts of these advancements.
Yeah.
You know, we need to ensure that AI is developed and deployed in a way that benefits all of humanity, not just a select few.
Yeah. It's a call to action for all of us, scientists, policymakers, ethicists, and everyday citizens. We all have a role to play in shaping the future of AI.
We do.
And ensuring that it aligns with our values.
That's crucial.
This has been an incredible deep dive, not just into the mechanics of AI, but into the very essence of intelligence, creativity, and what it means to be human in an age of rapidly advancing technology.
Oh, you know, it's ironic. We started by exploring a technique called test time training, a way for AI to learn during an exam.
Right.
But in a sense, we're all undergoing a form of test time training right now as a society.
I love that analogy. We're being challenged to adapt, to learn, to grapple with ethical dilemmas we've never faced before.
And just like those AI systems facing a complex puzzle, we need to draw upon our collective knowledge, our creativity, and our shared values to find solutions that benefit all of humanity.
So, listener, as we wrap up this deep dive, we leave you with a challenge. Embrace the test time training that's unfolding all around us. Engage in thoughtful discussions about AI. Demand responsible development and deployment of this powerful technology. And above all, remember that the future of AI is not predetermined. It's a future we are all actively shaping together.
Keep questioning, keep learning, and keep pushing for an AI-powered future that is both innovative and ethical.
Thanks for joining us on this incredible journey into the world of test time training and its implications for the future of AI. Until next time, keep exploring.